Hello. Good evening. Yeah, can anyone hear me? Hello, can you hear me?
Oh yeah, I can hear.
Oh, okay. All right, so sir. Wale, can you hear me? Bumi, can you hear me?
I can hear you.
Oh, okay. All right, so welcome to class today. So
Right.
what we want to do today is just introduce you as much as I can to IT generally, and then specifically to what we'll be covering in DevOps. Right? So we want to know what DevOps is all about, and then prepare our minds for the practicals, and then take as many questions as we may have. So just bring you up to the level where you can begin to understand what we'll do in class. All right? Unless we're able to if we're able to cover all of the questions you may have for me today, then we can go straight and start practicals. Otherwise, we can dedicate the whole of today to just taking your questions and making sure you are comfortable to start the technical training proper. All right. So I'm going to start from the very basics as much as I can, but don't be scared to ask questions. If it requires me to go below the basics, I'll be happy to do that, just so you have a proper foundation for the very technical course ahead. All right, so my name is Akin Aregbesola. Usually, okay, I'll just do. Yeah, it's nice that you meet me for the first time. Maybe me, okay. So that's me, Akin Aregbesola, if you recognize me. So I'm the head of theITern. So there's a different trainer that I'll be taking you after this inaugural session. And then I'll introduce him at the appropriate time. He might be joining us later today. Well, usually I'll see you at the beginning and then sometime in the middle of the training, and then I'll take over after the trainer has done the preliminary courses with you to prepare you for the big courses. All right. Okay, so 1, 2, 3, 4, 5 of us. Okay, that's fine. Hopefully this class will grow to ideally 7, 8 persons. All right. Our usual optimum class will be 10 persons, but rather a full class will be 10 persons. Well, I'm happy with 7 persons, 8 persons in the class. Or however it is, we started. Let's see how far we can go with this. Okay, so let's start the preliminaries. So I will need the whiteboard. That's my whiteboard. All right, so welcome to IT. IT basically means the connection of computers and devices together so that they can share resources. I'm still looking at my whiteboard. They changed things around here. Okay. Yeah, okay. Oh, okay. All right, so that's my whiteboard. So I'll try and put some of these things in diagram format so you can understand. I hope I'm used to. Okay, so that one is good. So I represent that. I represent a computer with that. Please bear with me. I'm not used to this new dashboard yet, so I'll just manage. So if we call that one a computer, even though we'll be talking about computers, but generally when we say computers, it could be a desktop, it could be a laptop, it could be even a mobile phone or a tablet. I mean, everything these days is on the internet. We call them Internet of Things, even your refrigerator, your car, everything. But instead of mentioning all of them one by one, we typically represent a device on the internet with computers. So I'll be mentioning computer, even though in reality, there could be any of those devices that I mentioned. So if we have the computer there, that's the screen and that's the keyboard. And all you're able to do with this computer is just word processing and printing. Maybe you have your printer connected to this computer in your room so that you can do your word processing. You can type a project, for example, and then print to this system. I mean, to this printer. If that is all that you have, then this is not really IT, because this is only a stand-alone computer. It's not information technology, it's not IT. You're just using it as a typewriter. All right? So we'll begin to talk about IT when we have multiple computers connected together. So in that case, you would have another computer here, maybe in a different room, not necessarily to be in the same room, but let's just say a different room. And then you have another computer here on a different floor of the same building, and so on and so forth. So that you now have 3 computers connected together. What's the reason you are connecting 3 computers together? What do you want to achieve? All you want to achieve is resource sharing. What do we mean by resource sharing? If, for example, you have a printer connected to this computer, you want these other computers to be able to print to this same printer without standing up from room 3 or from room 7 to the ground floor to room 1. If, for example, your internet is connected to this computer, in that case, you call this your internet server, you want that internet to also be available on this computer and on this computer, on as many computers as are connected to this same network. That's the idea of networking. All right? Even though we're talking about internet here, we're talking about printers here, in reality, we could be talking about databases, we could be talking about applications, we'll be talking about security features and firewalling, a whole lot of services that you want to make available centrally to many computers. So that is the reason you want to network the computers. And it is at this level of networking when 1, 2, 3, 700, 1,000, 1 billion computers can communicate with one another. That is when IT comes in. That's when you begin to see, I'm an IT person. And of course, being an IT person, there are different departments and different layers, like we'll begin to see now. But let's not go there. Okay, so for now, let's come back to this network. So we have a network like this, a small network within a building. Even if the building is 50-story building or just 1-story building. Once we have a network within a building, we call that kind of network within the building again. We call it local area network. Where's the, okay, so bear with me. Zoom just changed the interface, so it's not something. So we'll call it local area network, or simply LAN. So by LAN, we mean a network of computers, whether those computers are just 3 computers, or like I said, 300 or 700, as long as they are within the same geographical area. In this case, within a building, it is generally called a local area network. So this is the basis of networking. And like I said, everything IT, whether you are a networking person or a database person or an application person or a developer, irrespective of what arm or what unit or what department of IT you belong, this is the fundamental, the basis of the infrastructure on which you will be working. All right? Networking. And the smallest kind of network is local area network within a building. All right. So let us say that all of this, let's say this network is actually within a building of, let's say it's within the corporate office of a bank. All right. So all of this is a corporate network for a bank. Therefore, the bank would also have another local area network in a branch of the bank, and then maybe another local area network in another branch of the bank. All right. So of course, you will need to interconnect all of the branches together to form a bigger kind of network, right? So branch A, branch B, head office, corporate head office. So when you have another LAN here, another local area network here, let's label that local area network. Okay, right inside. Local or simply LAN. So we have one LAN there, and we'll have another LAN here. LAN. Then to interconnect this LAN so that computers from head office can communicate with computers from in branch office A and with computers in branch office B. When you have this interconnection of local area networks, we no longer call the resultant bigger kind of network local area network. We now call it enterprise network. So together, all the LANs would form a bigger kind of network that may be referred to, but there are different technical names depending on which you need to belong, that we want to call here enterprise network. All right. Enterprise network. Okay. All right. So back to the local area network here. So this is usually, not always, sometimes it's wireless, but the connection between the computers is usually wired. In other words, this line here will be a cable that is connecting this computer to a central device. This central device is called a switch. So you have a switch there. Okay, I'll just type that on. So that's the cable, and this is a cable that is connecting this computer to the switch, and this is the cable that is connecting that computer to the switch. So this switch is the central device. If you were doing wired, you are connecting all the computers using cables. All right, different kinds of cables for different purposes. All right, but the area of connecting cables to switch is not your area. That is for network people. So you have some IT guys, they call themselves network engineers. All right. So the devices that are responsible for interconnecting these computers are managed, configured and managed by network engineers. But the cables proper, they are laid and connected by not even engineers, by technicians. So it is after the technician has completed his work of laying cable and connecting the computers that the engineer may come in to start to configure all of the equipment to work together seamlessly. But that is not your area. All right. Even networking here is not your area, but I'm just laying it as foundation for you to understand what you'll be doing on top of networking later. All right. So there's something called switch. So it is the central device. Do I have a switch here? So it's a central device to which you run cables from all of the computers and you plug all of them to the switch. So the switch, is the one that will switch data coming from one computer, switch it to another computer so that those two computers can start to communicate with each other. All right. So that happens within the LAN. Again, when we're not talking about LANs communicating with one another to form enterprise network, then we have a different kind of device, usually situated here at the gate. So this device will be at the gate of that LAN. This device will be at the gate of that LAN. This device will be at the gate of that LAN. So this device that is usually at the gate, monitoring, allowing, or blocking traffic, either coming into the network or going out of the network. That device is generally called router. It is not your work. Network engineers are responsible. However, it's okay for you to know that in network, there is a device called router. All right, router is in it. It could be called router depending on the, sometimes it's pronounced. And then this other one is the switch. All right. So if I ask you now, on a typical local area network, can you name 3 different kinds of devices that you would find on a local area network? Then I expect you to say, of course, computers, servers, switches, and if you mention router, you are not out of place. All right. So I'm differentiating computer from server because when a computer has a resource, a service that the other computers within the network depend on and are asking for, then the computer that has that service, we call it server. In this case, the computer that has the internet here on this diagram is this computer. Therefore, this is the internet server. It is the same computer that also has the printer attached, so that on behalf of the entire network, this is the computer that prints. In that case, we still call this same computer your print server. All right? To differentiate between this computer that is serving and this computer that is receiving, that is asking for that service, we'll call this computer and we'll call this server. Otherwise, physically speaking, they are the same. All right? So do you see the place of cable, switch, router, server, computer on a network? You understand their place in this network? Yeah, so like we said, we are trying to just help you get the fundamentals right. So if you are not communicating, then I'm not able to know if you are following.
Yeah, I'm getting it.
All right, that's it.
Makes sense.
Oh, okay. All right. So now, when this network is beyond a local area network and it's going is beyond that building, especially when it incorporates many buildings and many networks. It's not about the building actually, it's about the network in the building. They will call them enterprise network. However, enterprise network is usually not only about the networks within the building. Enterprise networks is also, and very importantly so, about devices that are mobile. For example, mobile phone that are not even in the building. They are just, mobile phone are just whatever they can be. They are not restricted to a particular location. They are mobile. So it is not only possible these days, it is normal for mobile phones and mobile devices generally to be part of a network. So it is not just the building. So in other words, we now have enterprise networks that are made up of mobile phones and mobile devices as well, not just cable. So the difference between the straight line and the line I'm trying to draw, this kind of line, is that this one is wireless connection, this one is wired connection. Just for your information, nobody will require you to draw that, right? So when the connection is wireless, we use that sign. So usually, mobile phones will be part, or mobile devices, not just phones. Mobile devices will be part of enterprise networks, not just the local area network connection. All right. So if I now ask you, haven't given me at least 5 different kinds of devices that you would find on a LAN. If I ask you what devices would you find on an enterprise network, if you mention mobile devices, for example, mobile phone, you are very correct. It's part of the enterprise network. All right. So small networks, like going to work for a bank, going to work in the building as a computer engineer or as an IT person generally, requires you to know what operating system this computer uses, how to configure and manage the server operating system here, and know everything that you need to manage this network, compared to when you are managing an enterprise network. An enterprise network will be a big network like a T-Mobile network, for example. That's a big network of 400 million people. It's enterprise. It's big. It's not just restricted to one building or 2 or 3 buildings. No, it's big. All right? Very big, large networks. Especially the key thing to remember about enterprise network is that it is not just about the building and offices. It's now also, more importantly, about the customers. So there are always customers for a service. So like for mobile networks, the customers with the subscribers, who are the customers, integrating our mobile phones as devices onto that network is enterprise. So an example of local area network, otherwise called corporate network, is a bank, a one-man business, just a building. I mean, the typical offices you see around, like in front of me, irrespective of whether it has 300 rooms or it has only just 2 rooms, it's local area within the same locality. All right. So an example of enterprise network will be networks that do not just run their own services for themselves, but they also have customers that are using those services. All right. Example, telecom networks like T-Mobile, like Verizon. All right. Now, instead of you mentioning all these devices one by one, when I say mention, give me examples of network devices, switches, routers, cables, computers, servers, what else? Mobile devices, and so on and so forth. Instead of you mentioning all of those one by one, you can just bring all of them together and group them under a name. And that name is called network infrastructure. It means everything that works together to provide the framework on which the network is built. Network infrastructure. As a matter of fact, it is generally allowed these days to just assume to be silent on the network and just call it infrastructure. When we're talking IT and you say infrastructure, we know that you mean network infrastructure. Okay. All right. Again, if I say give me examples of network infrastructure, you may want to clarify, is it within a LAN or within an enterprise network? If I say within the LAN, the same examples you gave earlier on will fit in. Switches, routers, servers, computers, cables, and so on and so forth. Including not just the hardware, not just this physical thing, because everything I've mentioned so far, they are physical things. They are things you can carry, you can relate with them, you can take, However, there are also software that you cannot see, but you need them inside those hardware for the hardware to run and do the work that you need it to do. So they are also part of network infrastructure. So network infrastructure is not just always hardware. It is sometimes it's also software. So network infrastructure, let me just add that to the notes. There way to extend it. Would be yeah, I wanted to say it could be hardware or software. But... All right. So now small networks, corporate networks, bigger kind of networks, enterprise networks. Yet there is a bigger kind of network than enterprise network. So Once you have this enterprise network now, can we move all of this? Oh, awesome. We can move. Okay. So suppose we now have an enterprise network that an enterprise network could be a network in Texas that is covering Dallas, Arlington, in fact, all the state of Texas, everywhere. That's enterprise in nature. Even if it covers that, Texas and the neighboring state, it's still enterprise in nature. But what if you need a network like Zoom that will not just cover US, but cover, have a global footprint, cover the whole world. In other words, subscribers and customers of that service are not only resident in US, they are resident all over the world. So you now need something bigger than an enterprise network. What could be bigger than an enterprise network? Now, everything we'll be talking about in terms of local area network and enterprise network is mostly hardware. In other words, as the owner of the local area network or of the corporate network, I'll have to buy my own computers, set up my own servers, run my own cables, and own all of those physical devices, network infrastructure by myself. For enterprise, the same. Now, the modern way to do this is not to own all of this by myself. The modern way to do this is to, where is the tool now to say, okay, let me see if I can do this. So the modern way to do this, equivalent, that's the meaning, 3, is to go into somebody else's infrastructure. This infrastructure is resident somewhere as a service. So that instead of me buying this computer, connecting all of them together, what I'll do now is to go to this place and set up a computer, set up a server virtually, this time not physical. I'm not buying them. So I access this place through my computer, and I see the equivalent of this computer here in a virtual format called virtual machine. I see the equivalent of this computer here in a virtual format, so that instead of physically turning on my computer, loading my operating system, and doing the job that I needed to buy a physical computer to do, instead of all of that, I am now doing the same job, performing the same task on a virtual computer. So this concept of being able to access and setting up the equivalent of this in a virtual format so that I don't have to buy the physical infrastructure. That concept is what we call cloud. Cloud. So these resources are available virtually so that I can have access to routers and set up, just like I would have done physically. I can set up the whole of this infrastructure in somebody else's infrastructure. And when that kind of service is available to me, accessing somebody else's infrastructure and being able to do everything that I would have done on my own physical infrastructure, I say I have access to cloud services. Cloud services. I don't know if you've heard that before, so let me just. So cloud. So what does cloud mean? It is the virtual representation of what we have here. In other words, it's no longer a room made up of 50 computers, server room upstairs, so many workers, all of us going to work in the morning. No, it's no longer that concept. The concept now is that, such that you can access these resources from your own laptop, from your own desktop, from your own mobile phone, irrespective of your location, and be able to perform the task that you wanted to perform on this physical. We'll be talking about the task later on. on this physical infrastructure. You are not able to do it there. All right? So that's the essence of cloud. And this cloud, there are many cloud providers, many people, many companies that have set up this infrastructure on their own. When these providers set up infrastructure on their own, they set them up in a warehouse and run all the cables, put the routers like we try to describe here, and then make those services available to you so that you can access through the internet that warehouse, and you have access to resources, system resources and network resources. All right, so that warehouse where all of this hardware and the software reside so that the services are now made available to you as cloud is called data center. Data center. So even though cloud is virtual, it's not real, you are accessing resources without you even knowing where they are. They're actually resident physically somewhere in the world called data center, owned by the company that is providing that cloud services. And there are 3 of the hundreds of cloud service providers. There are 3 major ones that are very popular that are taking over 50% share of the market, or about that. The 3 major cloud service providers that have data centers all over the world, and through these data centers make cloud services available to people all over the world. They are Amazon, a company called Amazon, another company called Microsoft, and then another company called Google. These are the 3 major cloud service providers on commercial level. All right, there are so many that are providing cloud services for themselves, for their companies, for their own use, not for subscribers to come and buy and use the resources. All right, so the cloud services that Amazon as a company provides, they call it Amazon Web Services. Amazon Web Services. That's what they call. That's what Amazon calls their cloud service. And then for Microsoft, they call their own cloud service Microsoft Azure. Okay, Azure. Okay, and then Google calls theirs Google Cloud. All right, so these are the 3 major cloud service providers. All right, so did you get it to that level? Any questions so far?
I'm getting it.
Okay, so cloud is the bigger kind of enterprise now, so that you don't have to have your own infrastructure and go through the trouble of setting up your own links and connections to make computers communicate with one another on the network. There is no need for that anymore. So what's available now is that these services are already provided by these 3 tech giants. And once you just spin up your servers there and you spin up your resources there, then they are already available globally by the nature of the characteristics of cloud. They are already available globally, right? Otherwise, you will go through thick and thin to make a server available globally if you had to go through the traditional, the old way of doing things. So it is this concept of, oh, you cannot have an idea, wake up, and in 3 hours, that service, that idea is available to the world globally. That has changed the world in the way that we know it today. And that has made all of these jobs available in so much that you can train, you can come into a class like this, and within 4 to 6 months, you are ready. to go and start deploying these services, because people are always coming up with ideas, converting these ideas to business because of the ease of use, not just of the ease of setting up, configuring, and exploring the services available in cloud. All right. So because of cloud now, we talk so much less about local area networks. We talk less about enterprise networks, even though they are still relevant at enterprise level, but we talk more about cloud, and the services that are available in cloud to bring your idea to bear.
So
All right.
I have a question.
Okay. Go on.
So I just want you to mention, the benefit of cloud compared to local area network. Because as we are talking, I'm thinking about, okay, we still have to buy devices, right? We still have to buy laptops and computers, desktop for employees. So what is the benefit of cloud, other than, okay, you can be a multinational company and have operations all over the world, right?
Okay. Yes. Okay. So the benefits of cloud. Yeah, got you. All right. So let's see if we can create space for that. Okay, so now when you go to cloud now and you set up a server, actually what's available in cloud is server. Okay, so let's say you have a contract. You have a contract with T-Mobile to analyze all 400 million customers because they want to use that data that you're analyzing to take, that's the purpose of data analytics. They want to base their decision. Where's this company going in 4 years, in 5 years' time? They want to base their decision on statistics. So they want to look at the customer behaviors over the past 2 years and be able to draw conclusion from there so that they can take strategic and management decisions. Anyway, so you have that contract. So the contract you have is analyze these 400 million customers and give us this information, give us this information, give us this information about this whole database. What we do with it is not really your business, but I just give you an idea of what they are going to do with it. So if you have that contract, to set up, to analyze that, maybe you need like 70 computers with high processing speed, and then a good memory so that you can analyze at least 3 terabytes of data every day. And if you do that, it might take you, for example, 6 months to fully analyze the data that they are giving to you to help them analyze. They are paying you for it. So the traditional way to go about that is to go rent an office. You rent a hall, and then you buy computer, excuse me, go to the market, or you order like 700 computers, you employ people, the usual way you do it. I just want a contract. You buy generator, maybe not in this part of the world, but if it was in developing country, you buy generator, rent security, a lot of overhead goes into setting up those infrastructure. Before you now say, okay, finally I'm ready, come and inspect the infrastructure, confirm that everything is good, in good order, then give me the contract. Now, that is no longer the way to do it. The way to do it now is to use just a single laptop. I don't need to buy all of those, because everything I just summarized about getting security, getting engineers to set them up, buying those. After the 6 months, what do you do with those devices anyway? They become almost useless anyway. So the modern way to do it now is to go into cloud. So you set up For example, if you're using AWS, which is Amazon Web Services, you set up an account. And then you use your username and password to go into cloud. And you now have access to all the services available in cloud. You now spin up the 700 computers. Maybe not literally 700, maybe this time you're even talking about only 50 computers, but having the power of 700 ordinary computers, because there are levels of computers within cloud. So instead of taking a small computer of 32 gig RAM so that you can have 700 of them, why not take a computer of 218 gig RAM so that you have only 50 of them to do the work of 700. But the point is, you are now using a single laptop to go into cloud to set up all of those machines, eliminating the cost of generator, security, buying equipment, renting hall, and all of that. And everything now is available to you in cloud. You can set up. That's what we are training you to do. We are training you now to be able to go into cloud and set up all of those infrastructure within 1 or 2 days. And then you now get the data from them, and your infrastructure and your services, the services running on your computer are already in cloud. Push them into cloud, analyze all, just get busy within the next 3, 4, 5 days or a couple of weeks, and you are done. And cloud will charge you only for the time that those services were used, only for the time that the duration that the servers were up. So once you are done, in fact, you had no contract with them. Once you are done, you just shut down all of your computers. So you are paying only a fraction of the total amount that it would have cost you to deploy, to run that contract, because you did not have to buy all of those things that you needed to buy. In the case of workers, if you need workers, that's where they now hire people like you to say, you work from home. My servers are already in cloud. I already set them up. Or maybe you will come, I hire you to come and help me set up the server in cloud. And then you work from home, use your laptop to enter the cloud and do the work that I need you to do. And then in a couple of weeks, you are done. All right. So the big advantage is, instead of the traditional way of spending 3 million, going to bank to borrow money because you just got contract from T-Mobile. Oh, give me 400 million so that I can set up. They say, okay, go and bring the contract paper. That way is old way. The way to do it now is nobody will hear that you got a contract, because you are now using only one laptop to log into 700 laptop infrastructure, and you're able to do all of the job without even a third party hearing that you got a contract. Does that make sense?
Yes, it does. Thanks.
Okay, so you are no longer working in the physical world where you are working and everybody is saying, "Yeah, congratulations, how you?" No. You are now working virtually from your room and having even access to even more resources than you'd have had when you were spending $300 million to set up this platform. All of this has already been set up by these tech giants, and that's why they are the biggest companies in the world. By these tech giants, billions of dollars worth of resources all laying there, waiting for you to come and to have this kind of contract so that you can tap into them, use the resources, and once you are done, extract the result, send it to T-Mobile, and then you are done with the infrastructure. You move on with your work. You are not bothering about, oh, what happened to all of the money that I spent buying my computer? You never bought computer. You just leave them. You leave them for the duration and for the services that you need. So that is one big advantage. So in fact, that's the major advantage. So all you need is just one laptop. You are no longer buying laptops for your trainees, for your workers. You're not buying their laptops, you're not buying their equipment, because it's work from wherever. So they should have their own device to log in to the services that you will be using to do the work in cloud. You are not buying anything for them. The only thing they need from their end is internet access to be able to access cloud from their laptop. This is why work from home is common. Because apart from the fact that there are so many applications and software being developed to meet different solutions to different life problems, there are also contracts like this that will just come up. And then as soon as you are done with one, oh, that was a job well done. Okay, since you did that one, where you get another contract from a competitor company to say, okay, do the same thing for us. And then just things go on and on. So in cloud, you are not buying anything. You're not buying servers, you're not buying switches, you're not buying routers, you're not buying cable, yet you're accessing similar resources in virtual form. Virtual means they are not real. You are seeing them as just like I'm drawing now, but they are doing the work, like you will see now. You see how you begin to spin up server and use the server to host a website, and you are browsing the web. I can do it right here, and you'll be browsing the website. Just as simple as that. Compared to those days where you have to go and buy a powerful computer, load server operating system, and then 6 weeks to do. All right, so that's the big advantage of cloud. And it is for this reason that you are learning cloud. Because what you want to do, what you want to become after you learn cloud is to be able to set up in cloud what you would have set up physically. If you learned IT like 10 years ago, you'd have been learning how to set up these servers physically in the local area environment, even as well as enterprise environment. But these days, no, you are going into cloud to learn how to set up this infrastructure in cloud. And then after you have set up the infrastructure in cloud, you also want to learn how to put the relevant, the appropriate operating system and services on the infrastructure before you now make it available for the contract or for the application that they told you, that they employed you for, that they want to deploy on that server. All right. So to help you achieve all of that, we'll be learning these courses. We'll be learning a course called Linux operating system. So what is Linux? What does it do? I have to increase the font size. Okay. So when we mentioned corporate network, remember what we talked about corporate? Do you remember what corporate network is? So Windows is used in LANs. And LANs is called corporate. Another name for LAN is corporate network. Or all right. So if you want to work for corporate organizations, a single building organizations where they run local area networks, then you'll be specializing, you should know Windows Server Operating System. So that is not what we are learning. So we are not learning Windows servers because it's no longer common. Everybody is going to cloud now. So learning Windows Server for LAN is no longer common. But there's another operating system that is not necessarily used in LAN. This one is used in enterprise environment. This other operating system is what we call Linux operating system. It is used in enterprise. Enterprise networks. All right. So it is this same operating system that is used in enterprise network that is also used in cloud. All right. So to be able to go to cloud to set up services, to set up servers, to manage servers, then you need this operating system. You need to know how to use this operating system, what it does, and how you use it to set up services. So for that reason, we are starting this course with the learning of Linux operating system. Sometimes it's also called Unix/Linux operating system. OS Linux operating system. So we're going to learn.
I got a question.
Yeah.
So Linux is the only operating system used for cloud? No.
No, there's also Windows.
Okay.
There's Windows Server operating system in cloud as well. You see that.
Okay. Thank you.
Yeah, but 90%, or let's be modest, more than 80% of the time, the operating system, the preferred operating system will be Unix or Linux.
Okay.
So even as you begin to look at job description for the kind of role you'll be qualified for after training, you would hardly see Windows Server operating system requirements. All of them will require that you know, whether spoken or silently implied, that you know. In fact, you cannot do anything without Linux, because Linux is like the communication, what you use to communicate with server. Create directory, make directory, take this file from here, put it there. My employer wants to put an application here that will be available to the world. Let me prepare the server for the application to be deployed. Linux is the way to do all of that. There's no doubt. So without Linux, if I take you to cloud without your knowledge of Linux, you are just a spectator. You are just, oh, wow, but you cannot do anything by yourself. But with Linux, you cannot take the driver's seat and begin to drive. Without Linux, no, you are just a person. So the Unix is the general name for the kind of operating system on which Linux is based. All right, so for most, Unix is general, but more specifically, we call it Linux. So after Linux, the next course we want to learn is AWS. We said there are 3 popular cloud service providers, right? We cannot take them one by one. The time is, so we're taking the most popular of the 3. And the most popular of the 3 is AWS. So we're going to learn AWS Solutions Architecture. Did I miss that? Okay. So we'll go into AWS. And then in AWS is big, wide, with so many services, so many applications. But we'll be learning the curriculum of Solutions Architect, AWS Solution Architect. What does that mean? It means that we are going to learn enough services and how these services are used to be able to set up infrastructure on which applications will run. Solution architect, solution means a software, an application like Uber, like Dropbox, like Zoom, like dating, all of them are applications. So another word for application is solution. So AWS application architect, it means you are the builder that will set up the infrastructure on which application will run. I don't know if you got that. So in IT, there is software, there is hardware. That's in my hands, okay? So there is the infrastructure, and then there is the application that will run on that infrastructure. So together, they work. So there is the road, and then there is the vehicle that is working on the road. So there is the house, there is the infrastructure in the house, your kitchen, your sofa, your TV, and everything in the house. So there's always something on which another thing runs. So the basis on which something else will run, that is what we call the infrastructure. So you build the infrastructure. And then once your infrastructure is ready, what do you now do on the infrastructure? You take the software, the application, and you put it in the infrastructure. It will not run. It's just like the reason you are building your pipe is so that your fluid, your water, your petroleum will run through it. So after you finish building your pipe, you open your tap so that your fluid will run through it. After you finish building something, there must be something for which you are building it. So in the case of IT, when you want to run application, you first of all build the infrastructure before you now deploy the application on the infrastructure. So as a solutions architect, it means that you are able to go into AWS cloud and pick the resources that you need, pull them together to form your infrastructure. Does that make sense? Did you get that? Wale, are you there?
Yeah, we're getting it.
All right. Wale, are you there? We're just saying your name. You haven't said the words. John Paul, are you there?
I'm here, Mr. Akin.
All right. So are you getting what we're saying so far?
Yes.
Okay. So what's the reason we set up infrastructure? What's the place of infrastructure in IT?
I would say, so correct me if I'm wrong, for ability to set up systems or computers, for them to be able to communicate with each other and share resources.
Yeah, that's networking. That's what networking does. That's what infrastructure will do. But what's the reason you want to achieve that you just explained? What's infrastructure? Why do you really need to set up infrastructure? So that they can communicate with one another. What's the goal?
To increase productivity
All right. So who can help? So his definition of what infrastructure is, network infrastructure is correct, but what's the goal of setting up?
Let me try though. Correct me if I'm wrong. So I want to say the infrastructure is more like creating an environment where we can actually be able to run applications on.
Correct. So the whole goal of setting up infrastructure is to create the enabling environment for applications to run. So it is for applications that we are doing the work. The whole work of setting up infrastructure, of making sure they are communicating, making sure, and all the beautiful things you said earlier on, is for applications to run. So we are doing it for applications, correct? All right. So the person who is able to go into cloud to set up this infrastructure, what's the title? What's that person called? So for example, I have a new application idea and I need to hire
a solution architect.
It's called solutions architect, correct? All right, so good, you are following me. All right. So after you become a solutions architect and you're able to do that, the next course you'll be learning in this 4-month training is called infrastructure. Infrastructure as code. Using Terraform. Okay. So what does that mean? Infrastructure as code. When you became solutions architect, what you were doing was manually using your mouse, like I'm using my, can you see my mouse moving? Like I'm using my mouse now. You were using your mouse to click stuff in cloud. You click an EC2 and say, this is what I want. And then you type just like I'm doing now. But there's a different way to do that because the manual deployment of infrastructure is tasking and time consuming. Employers don't like that. They are paying you big money so that you can get things done very, very fast and save them time. So what they prefer is for you to run like a program. It's called code that would, once you run it, it will by itself generate everything you should have done manually, spending hours to do. In other words, it will automate the process of infrastructure deployment. You are going to learn how to write simple codes. In fact, you are not writing them. The codes are already available. We are going to show you where to pull these codes from online and then how to edit them to what you really want and then deploy them. And all you do is sit down and then you just watch things happening. They are just being deployed and they are coming up by themselves. Instead of you manually going into cloud to do them manually. I don't know if you got that. So one way to set up infrastructure is to use your mouse to drag and drop like you would do in Windows. That is okay. But a better way is to write a short code and then you run the code and the code will deploy the infrastructure for you. So because you are not doing it manually by clicking, we say you are using automation method. So anytime you are not doing something manually, but a code is doing it for you, we call it automation, right? So infrastructure as code is automating the process of spinning up infrastructure in cloud so that you are not doing it manually. And to do that, there is a tool that we are going to teach you to use. It's not so hard to learn. It's called Terraform. It's not hard because you are not building everything from scratch. In fact, these days, nobody builds anything from scratch, to be honest. So what we do mostly as IT people is we take a little from here, a little from there. We call somebody who has done it before, and then we just assemble them, and then you have something new. So it's only when you are new in the industry and you don't have enough libraries to access these resources, it may appear hard. But most companies already have all of these templates. And once you have access to the library, you just pull what they need. The only thing you do is just edit. You say, oh, last time they needed an EC2 of capacity T2 micro, or this time they need T2 medium. Just remove that, you know. Okay, but we're not going to the details now. What I just wanted to bring out from here is that the idea of being a cloud solutions architect is not complete unless you're able to do them not manually, but in an automated format. It is this automated format that we call infrastructure as code. All right? Automating deployment of infrastructure. Infrastructure, let's just say infrastructure in cloud using codes. That's the meaning of infrastructure as code. Any question on that? All right. Then after you have learned infrastructure as code, then the last thing we are going to teach you to get you ready for the market, it is actually at the level of learning this infrastructure as code. That is when you begin to gain edge over your competitors and you can start to call yourself an IT person. Otherwise, the others, anybody can learn them in 2 weeks, in 3 weeks, but they don't really give you competitive advantage. You only begin to say, yeah, I am ready at the level of infrastructure as code. And then the last one will be DevOps. DevOps, development and operations. That's the meaning of DevOps. And what does this do? This will now help you to deploy. It's another automation. Automate the deployment of applications. You know the answer that Esosa gave earlier? That the reason that we are setting up the infrastructure in the first place is so that you can deploy application on it. So this is the level now. This is when you deploy the application, but not manually, automatically. So the DevOps is the part of your learning where you do not only deploy the application in your infrastructure, you actually automate the process of deployment. So you automate the deployment of application in the infra that you set up above, the infra setup above. When I say above, I mean that you have either created using your skills as AWS Solutions Architect or using the skill of infrastructure as code. That infrastructure that you deployed, you now put application on it. All right, this is where you do DevOps. And you are going to learn so many tools to do. Yeah, the tools are many, but they shouldn't scare you. You are going to learn tools like Git, Maven, Sonar, Cube. Docker, Kubernetes, Jenkins, and so on and so forth. So you are going to learn all of these tools and how you use all of these tools to deploy your application, to automate the deployment of your application in infrastructure. So we're going to learn all of this. There are many tools. All right, we're going to set up GitHub, or either GitHub or what's the other repository there? Bitbucket. I don't know why this is. Okay, Bitbucket. All right. Oh, I got it. I know why that. Okay, then, and so I can't remember them all, but we'll learn all of this. All of this. There's Ansible. All right, and so on and so forth. So some of it. So it is after you have learned the use of all of these tools to automate the deployment of application in DevOps that you are now ready for the move. Yeah, Tomcat. Yeah, somebody's reminding me. Tomcat. We learn Tomcat and so on and so forth. All right. So have I successfully given you? Do you have a good understanding of the overview of what we'll be going through in the next 4 months? I can take your questions. Yes. Questions.
Okay, Mr. Akin, let me go first. So the question that I have, or the question I have is, you know, I was looking at the PDF download of what we're supposed to go through, and you know, month 1, month 2, and month 3, and month 4. So at what point, let's say everything goes according to how it is, at what point do you mentor us with resume writing, and, you know, to the best of your knowledge, what would that resume even contain? Say, you know, for someone who hasn't really had any experience in this field that he has worked in.
Mm-hmm.
Yeah.
Okay. Yeah, I got your question. Okay, so what I said marker here. Okay. So we'll not do this. We're not doing this. So we'll start from here. So your resume will contain this course and all the commands, all the projects that you carried out when you did Linux. It will contain the fact that you have completed AWS Solutions Architecting and that you completed 1, maybe 2 projects. So you carry 2 projects that you completed with this skill. Your resume will contain at least 1 project that you completed using this skill. And majorly, more than 50% of your resume will contain your ability, projects that shows your ability to use all of these tools in the deployment of application on the infrastructure. Now, that resume is already prepared. So the training is essentially training you to be able to defend that resume. So the resume that, a typical resume that recruiters are looking for, to say, yeah, this is the kind of person we want because he has all of these skills and all of this knowledge. It's already there, waiting for you. You already prepared. And the resume also says that, especially for people without IT background, says that you have done the first 1 year or 2 years of your IT with the ITern. So my name will be there as your referee. You see, it's called a background check. So when it's necessary to call somebody to say, so person claims that, usually you would have passed the interview. They would have confirmed that, yes, your knowledge of JIT, your knowledge of Maven and all of that is good enough. And it is very likely. In fact, most of the time they would have already made up their mind they're hiring before that call comes through. So I'll be there to say, yeah, I know Paul, or I know, yeah. So you can use, the resume allows you to use the ITern as the place where you did not just go through the training, but also had practical exposure and practical experience in this area. And when they want to call somebody to confirm if that is true, my phone number will be available for them. They can take the call on them. Did I answer your question?
Yeah, you did. And I actually have a follow-up question, if you don't mind.
Okay.
So I'll just frame my question like this: that personally, I have some experience in this field of trying to gain skills. Gain IT skills that that will be helpful. And past experiences that I've had was that at the end of the day, you impact the knowledge you have to us. However, the heavy lifting is done by us. And because, as they say, if you leave your computer for 2 minutes, it will leave you for 2 years.
Okay.
Right. So more or less, I just wanted you to sort of like confirm that thing that I know, that even when you impart this knowledge to us, it is left for us to, do much more, practice much more, basically just practice much more and have those skills and be able to understand what a typical scenario might be in a workplace when we say we go to interview. So I guess the question I wanted to ask is, will you also arm us with those skills that, because I'm not going to speak for anybody, I'm going to speak for myself, that I have never interviewed for an IT role. So at the end of it, are we going to be very comfortable and confident in the skills that we're going to be impacted with, that you get into an IT interview, you're able to defend them?
Mm-hmm. Yes, so that's what the training is about. The training is not theoretical. So the training is practical. The way we are going now, we even start the practical today. So we go into cloud and we do these things, and then you ask questions like you are asking now, and then you understand. And then the videos are available to you after training so that you can go over and over and over until you understand them and you're able to do everything there. And that is how you build your skill, layer by layer, one layer on top of another, so that at the end of 4 months, you are now able to do a whole lot of things. So, yes, we require that you are not just watching and clapping your hands and praising us that, oh, this is good, but you are also able to do what we are doing. So the skill is for you to imbibe. So as long as you understand the training, you understand what we do in the class, you understand the concept, and then you're able to practice on your own and you have that skill. Yes, because everything we are teaching is current, is new, fresh from the industry. It's not like something that is 2 years or 3 years old. That no, they are current. So once you understand them, then you are right for the industry. So the scenarios will be given, the projects will be working on, they are live from past colleagues. Many of them from your past colleagues. Because we don't say once they get job, then we cut. No, they will get feedback from your colleagues, from my colleagues, from senior people. So there's regular feedback from the industry so that whatever we are teaching here, it is what you're actually going to meet out there. So yes, there are two paths to it. We do our work by teaching you what is really out there. And then the second part is for you to practice on your own. So once we show you the path and then you tread it on your own, then you'll definitely get a job. You are not the first. The reason we are still in business is because the people before you are getting job and they are fair enough. Not necessarily because of the advice. All right. So once one person gets job, one more person is likely to come for, oh, you didn't do anything 4 months ago. Now you got a job of 100K. I want to go back. I want to go to that person who trained me. So I don't know where the fear is coming from, but you will see from day one. You would know for yourself that the quality of training, you will be able to tell.
Yeah, it wasn't fear. It wasn't fear at all. It was basically, I was hoping that you will reinforce, something that I already know. So it wasn't any at all expression of fear.
Okay.
Yes, it was just, I was hoping, that
I
you
may
will
ask.
reinforce. Yeah.
If I may ask.
Sorry.
Excuse me, can I ask a question?
Yes, go on.
So what does that reinforcement look like? Can you kind of give give a visual example of what that reinforcement look like? Because that word reinforcement is kind of like vague, and I'm trying to learn from your questions. So, and I'm kind of interested in knowing exactly what that reinforcement looks like. What do you mean by reinforcement? What do you what could you have done that would be, oh, this is reinforcement?
No, I guess
Are you
what Paul
asking
meant.
me or Mr. Akin?
Yeah, my understanding of that question. Yeah,
is she
I can take
asking
it.
me or is she asking you, sir? Okay, sir. Okay.
Yeah, I can take it. So my understanding of the question was something motivating, something to really convince you guys that this is it, this is the final bus stop. You know, something along that line, I guess. But I guess, yeah, Paul, was that what you mean?
I have a follow-on question, not a follow-up, a follow-on question. So is there a playground that somebody can go in? I know from what you said that it's practical. You also said something in line with, you will have some projects. So is there a playground that someone can go outside of class to, kind of familiarize, practice this, like hands-on, so is that a playground, some kind of a place that, okay, yeah, I'm standing up an instance, okay, this is how I do it, oh, I've stood it up, okay, you know what I'm saying, and then I can test it, and then you say, yes, it's good or bad, something like that.
You will, that's already the training. What you are asking, what we are doing in class.
Okay, cool.
Yeah. So we have all the manuals. In fact, it's you that will not even be able to cover what we have for you. So I don't see you, and then we are here to support you if you have problems. Your colleagues, your current colleagues and your senior colleagues, hopefully we still get this class up to 7 or 8 so that you have at least 1 or 2 experts amongst you. So everywhere around you, there are people that are there to support. So on your WhatsApp group, you have an issue. They told us this thing work. Why is it that I've done it? Take a photo, put it there on the WhatsApp group and say, well, I'm stuck here. And then we'll be there to support you. Oh, this is what you are doing wrong. You did not put command. So the manual and the training material by themselves, and then with us, myself and your trainer and your colleagues also there to support, you have more than enough. You have more than enough exposure. Now, as per the playground, and okay, did it work or did it not work? So we're not working in a simulated environment. Then you get used to it before you go into the live environment. No, we're working with the live environment straight away. So it will not be a matter like it used to be before this 2022 training, where you first of all do it in your room, and then you make sure it works before you now go to cloud. So like I said, from day one, right away, we are going into cloud, and you're using live IP. So if I say I deployed a web server and it's not working, it will show that it's not working. It's not like, oh, it just worked because we are using a standalone system. Let me now go and deploy it in cloud to see whether it will work. No, because we're already doing it in cloud. Yeah, you have it becomes clearer when we really start to do this. So I guess that your assumption is when we do it in classroom, after we do it in classroom and it works in classroom, if we do it on the field and it's not working, who do we run to? So that question will not even arise because there is no classroom. We are already working on the field, because being in cloud and doing it live, and then we are seeing it, and then you are doing the same, whatever we are doing, because it's in cloud. Remember that whatever is in cloud is already available globally. That's the way cloud is set up. You are also seeing it and you are confirming that, oh, it's working or it's not working. So that middle class of let's test it, it's not there. We are not using the traditional way of it, but it becomes, you understand it better when you start class. Yeah. So the manual will give you so many assignments. You might not even be finished all of them. You might not be able to finish all of them. However, if you still do need, if you become a genius and after you've completed all of the assignments and all of the projects in the manual, and even the ones that your senior colleagues are calling us to say, I'm working on this project, I will give them to you, and you're able to, that means you are more than ready, even before the end of the 4 months, to start your own job. The
So
challenges will be coming from everyone.
I have another question. So that 4 months, is it because it's part-time, or is it or that's I know you said something I know you mentioned 4 to 6 months. So is it because the classes are certain number of days during the week that it's 4 to 6 months, or that is the natural process? That's, you need, give or take, you really need 4 to 6 months to be able to have. Okay.
Yes, give or take, you need 4 to 6 months.
Okay.
If you do 1 month or 2 months, it just be, oh yeah, Yoruba, okay. There's something so we may just pack everything, we just go in, and then maybe you pass interview, but it's not really sinking.
Okay.
It's not really sinking. And then we do the training proper is 4 months. I still say 4 to 6 months because ideally you would need additional time to really acclimatize proper even after class. You know, it doesn't mean that once you are done with class, you just pass the first interview. All right, you may have to take a couple of interviews before you eventually get the job. You know, it might take another 2 months of extra work preparing for your exam. I didn't talk about exams. So the exam that I would recommend out of all of these courses will be the AWS Solutions Architect. So after training, you may want to spend the first 4 months to focus on training. Then after training, spend the next 1 or 2 months to prepare, do additional preparation for your exam. And then while your exam is going on, you're also attending interviews. Every interview, there's always something new to learn. Oh, this area, I wasn't very strong. So ideally, yeah, 4 months. Yeah, there have been cases like the last class, the January class that we had that I just finished in January, February, March, April, that I finished April. I think it extended to May because there was a slight delay. 2 people got job before the end of class. So yeah, there might be cases where people are fortunate to get job before the class ends, but most of the time you need up to 6 months to be able to confidently say, I'm ready now. Even though the training is 4 months. The training used to be 6 months, but we have found a way to, from experience, to pass this training conveniently in ways that you guys can understand within 4 months. So no need to extend it to 6 months.
Okay.
Yeah.
All right. Thanks.
You do it in less than, there are people, especially with people from non-IT background, 4 months is minimum for me, or just by my recommendation. If it comes less than that, it may not last. You just understand it while you are in class, and then if you just leave your system for only 2 weeks, everything might just evaporate, and you are wondering, what happened? That's how it is. So 4 months to 6 months is good.
I got a question. So I wanted to know what days are scheduled for the classes, because I live in the West Coast, so I can know if it actually aligns with my own schedule, because I work and I get off at least 5:30. And my second question is, for the class, are we going to go in sequence? I mean, what I mean sequence, are we learning the solution tech first before we go into DevOps, or we're actually diving into DevOps immediately?
You cannot go into DevOps so you don't know the tools. So we take Linux first.
Okay.
After Linux, sequentially like that. After Linux, AWS. After AWS, infrastructure as code. Then before, we now use all of the knowledge there to do DevOps.
Oh, okay.
In that order.
Okay, then
so classes
I want
are
to. Yeah, go ahead.
Tuesdays, and Thursdays.
And the time?
Time is 6 p.m.
Okay, 6 p.m. 6 p.m. Texas time, right?
Yes, to 9 p.m. Texas time.
Would the lecture be pre-recorded, or is it going to be live?
Yeah, as we are talking now, as we are in lecture now, it's being recorded. So as soon as we are done with class, it will be made available.
Okay.
Yes. Okay. So whether you miss class or you are in class, you would always have access to them.
Okay.
They are always recorded. Recording is going on right now. And as I ask you this question now, it's also being recorded. You see, you hear.
Okay. According to you, from your own experience, has there been a timeline that was shorter than 4 months for your student to learn the full concept about DevOps?
Maybe on their own, but following my own curriculum, no, it's always been 4 months is the minimum we have had.
Okay.
And so even the 4 months is tough.
Fastest.
It's just that it's the fastest we've had. It's just that our way of delivering have proven to be very productive. Otherwise, not everybody can deliver this curriculum in 4 months. So even though we are very detailed in terms of what the pieces that we need to grasp to understand the complex, we are still able to cover everything.
Okay. So sometimes when I look up for job descriptions, they mention DevOps, Azure, DevOps, AWS, DevOps, cloud computing, like you've mentioned before. So are we going to go through all of these, or both AWS, cloud, Google Cloud, and Azure, they have more like the same concept?
Yes, the concept is the same. Well, no, we cannot go through all of that. It's not in this single class. So our focus in this class will be on the biggest of them on AWS.
AWS, okay, great.
Okay. So usually when they ask like that, they don't use and. They don't require you to know all of them. They just say this stroke this. In other words, this or this. Okay. So what I mean is it's difficult to, it's not common to find employers requiring you to know, because they are only using one of them. They can't be using, it's not likely that they are using all of them. So employers may not are not likely to require you to know AWS, Azure, and Google Cloud all together. So they just require you to know the one that they are using. Most of them will use Microsoft, will use AWS. Then half of AWS has like 30% share of the market, 33. Then the next one is Microsoft Azure. That have like 16% share of the market. And then you now have 7 to 8% share of the market for Google. So of course, you want to go with the guy that has the biggest market. It simply means that most employers are using them. After you have no BS and you are very comfortable and you now want to add any of those, then you are good. But to learn the smaller ones before the big one may not be the best time.
All right. Thank you.
You're welcome. Yes. All right. Any more questions? Preliminary questions that will help you understand stuff. All right. So if there are no more questions, then I told you earlier on. So your trainer would be Femi. Femi is here with us, Obafemi Adegoke. And then he will start. We'll start with Linux. Then takes you to cloud. You set up your AWS account. You begin to spin up servers on your first day. But don't think that because you are able to spin up server, then you arrive for job. No, it's not that simple. We need to go all the way to DevOps before you now begin to talk about getting a job. All right, so if there are no questions, no more questions for me, I'll release you to go with Femi so that it starts the technical training. And then somewhere in the middle, I'm really hopeful that we're able to add more people. Somewhere in the middle of the program, then I'll take over and then see how it goes from there. All right, so right now there are just 4 of us. Yeah, I mean, somebody just left because he has to continue with work, but there are 4 of us. Let's see how we can do it. All right, so Femi, please, we don't really have to start practical today if we are not right for it. And just learn the concept one more time just to be sure that everybody's starting on the same level. And then once you're happy with your understanding, we're not going to into Linux. Do you have your link ready for class?
Yes, I have a temporary link, sir.
Okay. So post it on the group so that one will. Oh, there's somebody that's not on the group here. Who is it Wale? Wale, we have not added it to group. Can you send me a message so I can add it to the group there? And then
yeah, I think I did. Yeah, I think I sent you a message.
Okay. So I'll add you so you'll be able to click the link and join the practical group. All right, so that's about it from me. Is there anything you still need me to address before I do? All right. So I'm going to log out now. And then you log back in with the new link so that Femi can take you from there.
Thank you, Mr. Akin.
All right, John. So talk to
Thank
you
you,
guys
sir.
later. All right, and then in the group.
All right, thank you.
All right, then. All right, bye, everyone. All right, Bumi. Bye.
Bye.
Yeah.